There's a lot of different design styles in programming. You'll come across ones such as domain driven design, API driven design, event driven design. There's a lot of different styles out there that you can choose from. And I want to talk about one of my personal favorite ones, which is API driven design. API driven design basically is it's the design where you make your API first, or at least we'll call it the interface for your API. You stub out all the endpoints that you're going to expose to, whatever system you're working in. So in the context of my engine service, it could be something like I have an API that I can get an engine. I can post logs. I can post engine data up to my Rust service. So those are three examples of endpoints that I have in my system. API driven design basically is the premise that you start there first. You start with the API first. So those three endpoints. And then you set up the return. You set up, if your get is going to return data, maybe you can just have it return a 200 if it does an error out. Your posts you can handle. So you basically stub out the endpoints and allow them to be called. Then once you have the endpoints in place, then you go back and you add functionality to behind the respective endpoints. So in the context of my get endpoint, I would make a call to the database in a service or in a repository, and then I would call that from within my endpoint. The same with the post endpoint for posting data to my engine service, as well as the logging service that sends it to my queue. So that's the premise of API driven design, but I want to expand on it, and I want to say that API driven design is a way that you can really make testing a lot easier in your system, because I think the problem is one of the pitfalls you'll fall into with testing is simply adding tests for the sake of adding tests, right? Increasing code coverage is a good thing, but sometimes increasing code coverage it creates a false positive. It kind of gives you a false sense of security, right? Because code coverage only tracks the method, the lines of code that are in a method that are called from a unit test. But if that unit test is not doing anything except for checking that the response is not null or something just crazy, or even if it just exists, it'll come back that your code is covered by a unit test. But what is the quality of that test? Does that really change anything? And if you actually truly break something in your application around that method, is that test going to catch it? And I think that is the one danger of just chasing after code coverage as a metric of quality, because I don't think it really is. I think it's obviously good to have unit tests, but I'm not sure that a high percentage of code coverage means what you think it means. Because I think that if you truly want to have an understanding of the state of your system, you need to have a way to call all the specific functions in your system. So in my case, I have a engine repository that connects to my database. It returns all the engine details like the uh, horsepower, torque, temperature, displacement, all the things. And for me to test that, I can do a couple things. I can either create an in memory database to be used by my testing framework. I can mock the response from the repository. But the problem with those two things are one, the in memory database takes a lot to create, and it just adds a lot of, I think personally, it adds a lot of overhead and burden to development, because now you essentially have two databases that you have to maintain: your actual database that your system is actually interacting with, and now you have this in-memory database that you have to keep in line with the actual database. And then the mock, using a mocking framework like mock, you specify the return value. So you're not really testing the connection or like the data coming back, because you've already predefined that. And the problem with this is that none of these achieve a true test. There's integration tests that aim to solve this, but it really depends on what you're integrating with. Because if you are truly testing end-to-end parts of your system, it's got to be an environment that's mirrored to what the state of your system actually is. So in the context of API driven design, this the premise of this I think can be expanded to how we write tests. So in my context, here I have an API, the engine API. I have the repository, the engine repository that connects to my database. What I would need to do is for every repository method that connects to a database and executes a query, I need I need to write an endpoint for each of those queries. Now that's going to seem like a lot of overhead and may seem unnecessary, but the reason I want to do that is because now every part of the connection to the database is now instantly testable by a simple call to an endpoint. Then if I use something like Postman, I can create a collection runner that calls all of those in one go, and I can see the immediate response back. And I can test changes to my query. I can test history of what the query did before and after a change. And I don't have to step through any code to get to the execution of the query because I have an endpoint that I can call to perform that right then. And the reason I think that this is powerful is because those endpoints don't have to be exposed, right? They can be hidden behind any kind of authorization logic you have in. So let's say you make a testing user or a testing role, I should say. Then you just wrap those specific methods behind that testing role. So in order to test those, you have to have the token for the test role, and then if you have the token for the test role, you can be granted authorization to call those endpoints. So you've locked it down to a test role that you can use to test these. So they're not publicly exposed. You can hide them from your Swagger docs, and you can use authorization to shield them from unwanted access. But I understand that there's a little bit of burden on writing. Okay, obviously additional endpoints. You maybe like additional service methods, but I would argue that it's better in the long run because of the difference in how you can test. Right now, you don't have to worry about creating an in-memory database because you should be able to use some other test database or something available to you that's a mirror off what your production database looks like. And if you have that in place and you have that all running locally and you have all these endpoints, you can immediately test all your changes. And I think it's follows practice to what API driven design really aims to do is it makes everything easily testable, decoupled, and it makes development very, very easy because nothing is more frustrating than trying to write a unit test around a very complicated method, right? Methods that are very long or calling multiple other services or executing multiple database queries. That's not an easy test to write at all. It's very complicated because of how many different things you have to test for, right? It just makes it difficult. And so yeah, you could argue that you should split those into different methods, and then test each of those methods and things like that. But it just becomes a big hassle because how are you going to if it just turns into a big hassle as opposed to writing specific endpoints. It turns into a big hassle compared to just writing endpoints that connect to your database that call the queries that you want to test. And by doing this, it also forces us to write our service methods a little cleaner, right? Because if we follow the model of you have your controller, your service, and your repository, that's a pretty classic pattern, and it works very well. But the problem with that is sometimes those service methods can just keep growing and growing and just get out of control to the point where it's because it's easy, right? Because it's when you're writing something, when you're writing code, it's easy to write code quickly and say that you're going to go back and refactor it, but the likelihood of that happening is probably pretty slim. I mean, let's be honest, because we get lazy and we forget about it. We put, we might make a note of it, but it gets lost compared to all the other stuff we want to work on and pick up. But if we focus on writing the endpoint first, and then writing the service and then the repository or some variation of that, as long as an endpoint's being made, I think it's going to change it, because it's going to force us to think about how do we keep these small, but how do we make this easily testable. I mean truly easily testable in a way that actually makes sense, because I just don't like. I think unit tests have their place. I think they have their place, but I just think that sometimes they can be misused, and they can be having 100% code coverage is a good thing to have, but I think it can be I think it can also have the opposite effect. It can be a bit of a false positive in terms of the integrity and health of your system. And so I think that if we explore alternative avenues of testing, like using Postman and setting up a collection to test your whole thing, I think that really transforms how we look at the system. Because if we burden down our deployments and our system with so many tests, it becomes quite complicated very quickly. I mean, if you write a project yourself, right? You're working on some kind of API. You start adding tests in there, and you test the functionality of maybe methods that are performing some kind of logic. But then you're going to start writing your tests for your queries, your database queries, and then you have some decisions about how you're going to do that. Because if you're testing the methods, the service methods, you can mock the repository responses. Just use mock, and then you call the setup method, then you give it the type, and then you specify, okay, return this when it's called, and that's it. And then that provides you a way to test the service. But are you actually testing that repository method? I mean, are you actually seeing what that does? And do you know if the query, if it changes, do you know how it's affecting, the response? Are you still expecting that response to come back? Because versions of databases may change, and SQL compatibility may change. Maybe if you even change an entire database engine, you have to know what the SQL is doing. So if you have to go in and copy all those manually and then put them in your SQL, database, and then execute them manually, that's going to be a pain. But if you already have that testing set up in place with endpoints, you can do it very easily. Very easily. You can always know that your data is returning back how you want it. And so when somebody talks about API design, or if you're talking about it to somebody, it's a good development practice to follow, but don't stop there. Apply it to testing as well, and just see where the conversation goes. See if you can think of new ideas on how to test. And I would argue too, it can be broadened to how we test our queues, because I think those should be tested as well. Because how do we know the connection to the queue is good? How do we know the response how do we know the response value from what the queue is what we're expecting? How do we know what we're sending up to the queue is what our system needs, what the structure of the data? How do we know that? So I think that this conversation can be broadened to how we test our connection to RabbitMQ and those kind of things with our system. So in the context of my engine API, I really am thinking about how I want to make a series after the system design series about testing, because I think testing is just a massive topic. But I can tell you what I don't want to do. I don't want to do unit tests like a series. I don't want to do a unit test series. I might do a couple of unit tests to show you like how to put them in and stuff like that. But what I want to get to is our true integration tests of the system, because I think that's where the value, that's where a lot of the value is found, in my opinion. So let me know your thoughts about API-driven design. We'll get into event-driven design later on, but I wanted to talk about this because I think it's important, and I think that we could think about a lot of ideas around this topic. I truly do. So that's all I got for today. I'll see you in the next one.